So we had our capillary tube, and we put it in some liquid. And as we recall, we put some nice pink liquid in that capillary tube, and the liquid came up in the capillary tube. Now, what have I done here? I was supposed to make this liquid come up at a nice, just right up to the tube, but here I've drawn it with an angle. We call that gamma is equal to the contact angle. And while the surface tension of water against air is still the same, only a fraction of that surface tension is now contributing to the upward motion. And if we look at this is gamma, that's the hypotenuse, this is the adjacent. So what we see is that the cosine of gamma times the surface tension is equal to the upward force. So what this does now, instead of having P equals 2 sigma over r, we now add a new term. We say times the cosine of gamma. Okay? And so this is the impact of the contact angle on this pressure that we felt in this pink fluid. Okay? Now, one of the things I really want to emphasize is that we specify this in terms of the air-liquid surface tension. But that's really just because that's the only thing we can measure. When we measure surface tension, we have to have a little device which pulls a ring out of fluid, and we can actually measure that. It's very difficult to measure the actual energy of the liquid-glass interaction or the glass-air interaction. So really what's happening in this case is that the glass-air interaction is not sufficiently negative to pull the water up. And so it's only partially pulling the water up. So really what's happening is we have, remember the force balance between this force per unit area and that force per unit area pulls the water up. But if the force of if the contact is not sufficient, so that we don't have a high energy interaction between the liquid and the glass, then it will only pull a less amount than the surface tension of the water, giving an apparent contact angle. And our capillary pressure will be reduced by the cosine of that contact angle. So this is how we adjust the capillary pressure for the contact angle. And this is particularly important when we have things like oils. And when an oil enters a moist soil, the contact angle can sometimes even be negative, where the oil is repelled from entering the soil. So this contact angle does influence the movement of liquids in soil, particularly when the soils are contaminated or when we're putting non-aqueous phase liquids into the soils.